So we're on chapter 4, section 2, day 4. First we're going to talk about arc length. So let's do a little quick sketch of what I'm talking about. You have XY axis. Put an angle on there anywhere you want. The value of the angle is not really important. The arc length, arc is the curved part, right? So it's the length of the curvy part that would connect the angle. That is the arc length. It's a linear measure, meaning like you can just measure it like with a measuring tape or something like that. It's inches, feet, meters, some sort of measurement like that. And theta theta equals S over R.
They think it's interesting.
That's your formula. You're good. Where, as always, what does theta represent? The angle, yeah. What do you think R represents? Yeah, the radius. And so that leaves S to represent arc length, because that makes sense, right? I feel like I looked up a Y is it S one time, but I don't remember what my result was. S is arc length, just what it is. S represents arc length. Yep. All right, so we're ready for an example. That's what arc length is. That's its formula. That's the teaching part. Now let's do the practice part.
Okay.
First example. If you are given that theta equals pi over 4, and that the radius is equal to 5 centimeters, find S, or find the arc length. Okay, so I'm going to use the formula that I just gave you right here, which is theta equals S over R. So if theta is pi over 4, that goes here. And that is equal to S, but I don't know what S is, so I leave an S, over the radius. So you can include the units with the 5 in your when you do your calculations. I prefer to figure out my units separately and then not move them around inside my equation. So I like to just take the number part 5 and know that's 5 centimeters. And I know that arc length is also a linear measure. So I'm going to need some units on my final answer. Radians doesn't have a unit with it. And radius has centimeters with it. So that tells me my arc length will also be centimeters. So I'm not putting the centimeters in here. If you're someone who likes to do that and move it around together, go ahead. It's up to you. That's just your preference. So I want to get S by itself, so I need to multiply by 5. If I do it on one side, I got to do it on the other. So those 5s cancel. So this gives me S equals 5 pi over 4. And I know these are centimeters because I just talked about that. That is the exact answer, but whenever you do a linear measurement where you're going to go measure something, you normally don't have pi in your answer, but that is exact. And your book tells you for the homework I'm going to give you to round to the nearest tenth, so we'll stick with that and say that this is also S equals 3.9 centimeters. So you're just going to type in your calculator 5 and then the pi button, divide by 4, and it will give you 3.9. If you do your input in the calculator as a fraction, it's going to give you the output as a fraction. So if you're looking for a decimal answer, You need to put it in as numerator divided by denominator for all of these. Okay? And that's that. Then I'm going to give you one more example. This is about as hard as these are going to get. It's not that bad. So given that theta equals 60 degrees and that the radius equals 2 inches, find S. Oops. S. I don't like that. Go away. Okay, so in this problem, if I want to deal with my units first, predict the units of my answer, I see the radius is in inches. So that tells me my arc length will also be in inches, but I have this degrees. So the way it is, my answer is going to be in whatever number degrees inches. And that doesn't make a lot of sense, does it? Like, have you ever heard of someone saying 5 degrees inches? No, that's silly. So we need to change this to something that doesn't have a measure, which would be radians. I didn't say that right. For something that doesn't have a unit. So I'm going to turn my degrees. So if your problem is in degrees, you have to convert degrees to radians. So I'm going to take this 60 degrees and multiply it by a conversion factor. And I know the conversion factor is a fraction. Since the conversion factor is a fraction, I want to make 60 degrees a fraction by putting it over 1. So I want degrees to go away. So that means I need degrees in the denominator to cancel it. So I'm going to put the 180 degrees in the denominator. And if I want radians, that means I need a pi. So I'm going to put the pi in the numerator. Then my degree will cancel the degree. So it's 60 pi over 180, but if I have a 0 in the ones place, that tells me I can divide them both by 10 to get rid of the zeros. So my first round of simplifying gives me 6 pi over 18. But I can tell by looking at it, that's not simplified all the way. 6 and 18, they both divide by 6. So I could make this pi over 3. So my radian measure of 60 degrees is pi over 3. That's the same thing. So now that my theta is in radians, I can go to my formula. And I'm going to do this one in a slightly different order, so you have an option if you prefer to do it this way. Theta equals S over R. If I know that I'm solving for S, like in the first example, I plugged my values in exactly the way the formula was given. I could, if I would prefer, get S by itself first and then plug in the values. If you like to do your solving with the letters before there's numbers involved, you could do that. I know I'd multiply by R on both sides. It would cancel this R. So that would be R theta equals S. So I just rearranged the formula first, so it's solved for S, and then plug in my values. Value of the radius was 2. My value of theta is pi over 3. And that equals S. So S equals 2 pi over 3 inches, which is the same thing as 2.1 inches if I round to the nearest tenth. And that is arc length. All good there? See, I told y'all it was easy today. Next is area of a sector. It's still going to be easy. It's okay. No, there's two things in the title. So I had part 1. Here's part 2. Area of a sector. All right, so you got to think of what is a sector. I like to think of it as a section of the circle. So if I sketch, again, XY axis, put an angle on there anywhere you want. I'm just going to do that one. And we just talked about this curvy piece that encloses the outside. So if I had, oh, I forgot to tell you all that. On the arc length, just describing on what it is, the arc length of a 360-degree angle, which would be the circumference of the circle, right? It would be the curved part all the way around. So if the angle is 360 degrees, it would be the circumference of the circle. So it's the pieces that make up the circumference of the circle. So we have an angle that's bounded by an arc. The area of the sector is the area bounded by the angle and the arc. And because its area, its units are squared. Just like with a rectangle, length times width would be feet squared, inches squared, whatever squared. This formula, the area equals 1/2 of the radius squared times theta. Okay. And your example, if you are given that theta equals 7 pi over 8, and that the radius equals 3 centimeters, then the area equals question mark. What is the area? So again, on this one, I can predict my units before I begin my problem, because I know my radians don't have a unit. The radius is in centimeters, so that tells me my area is going to be centimeters squared. And now I don't have to worry about units anymore. I can just do the problem. So the area equals 1/2 times the value of the radius squared times theta. So the radius was 3, and my theta is 7 pi over 8. Okay. I like to simplify it a little bit before I go to the calculator. And if you have to show at least the minimal work for this to show your work would be writing down what you're typing in your calculator. Like that is absolute minimum that you need to write down. But I would prefer this simplified a little bit, because I know 3 squared is 9, and 9 times half would be 9 over 2. So I can say 9 over 2 times 7 pi over 8. And I don't see any values that can simplify, so I could turn this into area equals 63 pi over 16. And then I could put that in the calculator. So the area equals 12.4 centimeters squared. And there you go. So your assignment. It seems long, but these problems go really quickly. We're still on page 238 to start. Numbers 27 to 32, which is your area, your arc length section. Then 43 to 49 is your area of a sector section. And then 97 to 100 is just more of your critical thinking, SAT prep type questions. Round everything to the 10th.